Hello and welcome. This is Chapter 2, Section 4, Zeros of Polynomials, Part B. So here are our objectives today. We're going to be using the TI-84 as well as constructing a polynomial function giving a set of zeros. So our first example is using a graphing calculator to find the zeros of a polynomial function. This is identical to what we've done in the past with like quadratics or anytime we find a zero. So let's jump up my calculator here. Now the first thing we have to do is just type in the y equals. So press y equals and start typing in 3. This is our x to the power of 3. Make sure you press the right arrow to go down. Minus 9x, and we can use the square symbol. Plus 3x, and then plus 2. Again, we press graph, or press enter, and then press graph, and it will look like this. Notice we have 3 zeros there. So it looks like it crosses the x-axis here, here, and here. So there are 3 zeros we're going to be writing down. And we should know that it would have at most 3 because it's x to the third. The fundamental theorem of algebra, which we'll talk about later, is telling us there's 3 zeros, exactly 3 zeros, both real or imaginary added together. So let's go ahead and find them. So let me get into this graph. So we go back to our second, and we're going to calculate. So second and calculate the zero. So go second, calculate, and then we go down to 2, or press 2 and press enter. And notice how it's right here. So we have to make sure we're below that 0. So the left side of it. So left bound says below and to the left in this case, or just to the left of it. The idea is we have to be above and below the x-axis on them. So I press enter here. And then I have to go back to about the 0 and then make sure I just go above it a little bit to the right. Press enter and enter. So the first 0 I have here is at about negative 0.32. Now we have a couple more here, so let's go ahead and keep walking our way through them. So again, second is your first thing you do, and then trace or calculate is what it is. So second, calculate, the blue button gets to the blue stuff, press 2, and then we just go over to the other 0. I like to go by it or right on it if we can, and then just go left a couple clicks, press enter, go back to it, go right a couple clicks, press enter and enter again, and then we have our next 0, which is at 0.83 if we round it to the nearest hundredth. Now if you go ahead, I want you to try this next one on your own to see if you can actually get it yourself. Hopefully you tried it. You should get this as 2.49 if you round it. So that should be 2.49 as that last 0 if you checked it yourself. So our next question is using the rational zeros theorem to find all of the zeros of the polynomial, and we're going to be given complex zeros. And this is the one where we've done the rational zero theorem where it's like you can plug all those in and use the factor theorem to check if they're factors, which we're going to use our calculator this time to find the real ones, and then we have to find the complex ones. So there are 4 zeros. And we don't know if they're all rational or if they're complex or whatever there are, but I'm guessing there are at least one. Well, it does say there's at least one rational 0. I'm guessing there's going to be 2, otherwise it'll be very hard to find the other one because we would probably have to make a depressed cubic and go from there, but let's do an easier way. So what I'm going to do is say, remember the factors of 5 over the factors of 3. Those are the potential zeros of that. So we could have 5 or negative 5 or 1 or negative 1 and so forth, and then thirds as well. I'm going to use my graphing calculator to help find this. So how do you do this? So first is you type in the y equals. So we have 3x to the power of 4. We have plus 19x to the power of 3. Push it down to the right, plus 20x squared, and then minus x, and then minus 5. Double check that you type it in right, otherwise you will make a mistake, and that is not good. So press graph, and we can see that there are zeros right here, here, here. There might be a couple in there that I can't see. I don't know which ones they all are, so what I like to do is use my calculator table feature. So the first thing is to note that we're going to have the factors of 5 over the factors of 3. And the smallest fraction that these could be is thirds. So what we're going to do is we're going to make our table, and it's going to go up by thirds. So whatever the smallest thing is, you're going to go up by that. So going back, we're going to go into our calculator and press second table set. And let's start at 0. And then we're going to go up by 1 divided by 3 for my delta table. Oops, sorry. I got to go back here, delete that, so clear that. And that should start at 0, like I said, 0. And then this, the change in table, the triangle change in table is 1 divided by 3. And it'll be 0.3 repeating. And now we go back to second and table. And now we're going to look in the right column, the y column, where is it 0? So I'm going to keep going up and up and up and see if there is an actual 0 there. And the funny thing is, I can see one already, even though you might not be able to tell, that is actually 0. So we have -1 is a 0. So one of the zeros by my calculator is in fact -1. Now I'm going to erase that because I'm going to go up and look for more. So there was another one if you look back at the graph. So just go back to the graph. Let me get in there. So graph, if you look back, there was one at -1, it looked like here. It looked like maybe around +1, but that wasn't anything there. So let's keep going this way. It looks maybe close to -5. So let's go back to the table, press second and table, and then keep going down till about -5, which at -5, in fact, there is another 0. So we have a zeros at -1 and -5 based off of my calculator. Now we can make sure that is true very easily. So let me erase this quick and then move this calculator out of the way. And, I actually got to move this thing out of the way. Okay, so now what do? Well, we're going to use synthetic division with those to find the other missing 2 zeros. So let's start with -1. It doesn't matter which one we use, but let's plug in the 3, the 19, the 20, the -1, and the -5. Again, if there are any missing zeros, or any values for x's, so if there was no x's, I'd have to put a 0 there. Synthetic division requires that you drop the first number, we multiply to the corner, and then we add down. We multiply to the corner, we add down, multiply to the corner, we add down, multiply to the corner, and add down, which we have to get a 0 here. If I'm telling you it's a 0 here, it has to get a 0 as a remainder here by that factor theorem. Now, the cool thing is, we've already done the work for this, so we can just set up synthetic division another time. So now we're going to do another shelf, but this time we're putting -5 in the quarter, and we're going to do synthetic division with these numbers, because that's my new polynomial, the coefficients already written for me, and I will follow through with that. Again, we drop the first number, we multiply to the corner, add down, multiply to the corner, add down, multiply to the corner, and add down. And again, I have to get 0 here, which is a check. Now this represents what is left as my part of the polynomial after I take out those 2 zeros, or those 2 linear terms. So what we're going to do is now use the quadratic formula if we have no way to factor it. And sometimes you can factor it, sometimes not. So the opposite of b here, so b is 1 here, so the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We are going to simplify that. If we do that, we get that x is both equal to -1 plus or minus. Let's see, that'll be positive 12 plus 1, which is the square root of 13 up here, all over 6, which will give me 2 values. So how do I write this down? So how do I write all of my answers down? Well, remember our zeros. Our first zeros were -1 and -5. Now these 2 zeros right here are -1 plus the square root of 13. And I'm going to put each part over 6 because we are dividing 6 to both of those. And then we're going to do the next one, which is -1 over 6, and then minus the square root of 13 over 6. Those would be all of my zeros. So nice zeros and complex zeros. So I would like you to check one of these, and these will be something that you will see on a test. So I would expect you to be able to do this. You'll use your graphing calculator to find the rational ones, and then do synthetic division to find the irrational or complex zeros. So please try this on your own because you will be tested on this as well. I hope you tried it. If you use the TID4, you should find that 5/3, because we're doing 5 3rds is what we're going to go up by, because it's the biggest number here. So if it was 9, it would be up by 9ths. If it was a 10, we'd go up by 10ths. That'll help us find what the 0 is. Put that in the corner, which it's really nice. We get all of those nice numbers. It gets 0 here. Notice that they all have a 3, so 3x squared, 3x, and 3. You can take that out. So then we can just look at this part and do the quadratic formula. So we have a 1, a 1, and 1. Put those all in for a, b, and c, and we should get that these are my other two zeros. So we have this and this, which is that, and the 5/3 for my 3 total zeros.